Welcome students once again, this time for class 12. Now we are discussing on the P block elements. We have done already 2 classes on that, and lastly we have discussed on the preparation of ammonia gases and some of its reaction. Now today in this class we will start with some reactions of ammonia. For example, first of all, reactions of ammonia with metal. Ammonia reaction with metal, that is sodium plus NH3, sodium amide or sodamine plus hydrogen, Na plus NH3 equal to NaNH2, 2Na plus 2NH3, 2NaNH2 plus hydrogen. This is sodamine. It is an important compound used in organic chemistry, that is, it is a reducing agent and used to treat some organic reaction. Next one, reaction with Nessler reagent. Now, Nessler reagent is used to treat the sample or any sample for the presence of ammonia or amine group. Now, here Nessler reagent, that is Nessler reagent formula, that is K2HgI4. When it is treated with ammonia in KOH medium, that is in basic medium, then it is a compound form, that is H2N. It is called iodides of Milan base, H2N HgOHg I plus 7Ki plus H2O, 2H2O. So K2HgI4 plus NH3 plus 3KOH, this is called iodides of Milan base. Milan's base. So it is a very important reaction. Next one, that is reactions of metal. Reactions of metal with ammonia. For example, any halides. Reaction with metal halides. Reaction with metal halide first. FeCl3 plus NH3 plus H2O forming FeOH whole thrice. In the same way, if we take aluminium AlCl3, then we get AlOH whole 3. Now all the PPT has an individual color by which we can detect the presence of such kind of salt. So first of all, it is the preparation of sodamide. Then second reaction with Nessler reagent, that is the preparation of iodides of Milan base. And third one is the detection of metal by using ammonium hydroxide solution. How ammonium hydroxide is prepared, we know, that is, it is the aqueous solution of ammonia, as ammonia is highly soluble in water. Next one, compound of nitrogen, that is nitric acid. Nitric acid, that is HNO3. Here the oxidation state of nitrogen is equal to +5. Now nitric acid, the formula for nitric acid is equal to HNO3, and it is represented in the form of is the planar structure of HNO3. So it is the planar structure of HNO3, and there is also a resonating structure for NO3 minus. Resonating structure for NO3 minus, that is 1 minus O minus N plus. It is the resonating structure of NO3 minus. So nitric acid, here the oxidation state of nitrogen is 5, and this is the structure. Now next, that is preparation. Preparation. First of all, preparation is done by using a salt, that is sodium nitrate, NaNO3 plus H2SO4, forming NaHSO4 plus HNO3. It is the laboratory preparation. Lab preparation of HNO3, that is sodium nitrate plus H2SO4, forming sodium sulfate, sodium bisulfate, and HNO3. Another one, in large scale. In large scale, it can be produced by Oswald process. Oswald process. What is this Oswald process? The Oswald process undergoes some step, that is, first of all, it is the oxidation of NH3 to produce NO, and then NO is oxidized to NO2, and then NO2 reacts with water to form HNO3. So here first step is the catalytic oxidation of NH3 to NO. Second step, NO plus O2 to form catalytic oxidation, NO2. Third step, NO2 plus H2O to form HNO3. So this is the Oswald method to produce HNO3. Now the next point, that is some reactions of HNO3. Now HNO3 is a strong oxidizing agent, and it can be used in three forms, that is reactions with HNO3, that is HNO3 can be used as concentrate HNO3 or dilute HNO3 or very dilute HNO3. In these three forms, HNO3 may be used. In concentrate HNO3, the byproduct is NO2. In dilute, it is NO, and in the very dilute case, it is the salt of nitrate. So HNO3 when concentrate, the byproduct is the salt formation plus NO2. HNO3 in dilute form, it is the salt plus NO, and in the very dilute form, salt of nitrate plus the salt of the metal. Suppose take an example, that is copper. Copper plus HNO3. This is dilute. Now copper nitrate plus, as it is a dilute, so NO plus H2O, Cu plus 8 HNO3 forming 3 CuNO3 whole 2 plus 2 NO plus 4 H2O. Now if we take concentrate HNO3, then Cu plus 8 HNO3 concentrate forming copper nitrate NO3 whole 2 plus NO2 plus water. Now for balancing, Cu plus 4 HNO3 forming copper nitrate plus NO2, 2 NO2 plus 2 H2O. Now in the same manner, if we take the example of zinc, then also we have to form zinc nitrate and water, and N2O for zinc nitrate in the concentrate form we will get NO2. So these are some examples of nitric acid with a metal. Now if we take another one example, that is for iron, then we will get iron nitrate or ferric nitrate plus NO2 plus H2O, or ferric nitrate plus NO plus H2O. This NO or H2O according to the concentration of HNO3. Now, as nitric acid is an oxidizing agent, it can also oxidize the non-metals in concentrated form. That is, the phosphorus, the sulfur are oxidized in concentrate HNO3. So we have to study the reactions also, and it is also given in your NCERT textbooks. That is, when sulfur reacts with HNO3, when phosphorus reacts with HNO3, and etc. So these are included in your NCERT book. So when sulfur reacts with HNO3, it produces SO2. When SO2 reacts with water, it produces sulfurous acid. When iodine reacts with HNO3, it produces iodic acid. When carbon reacts with HNO3, it produces carbon dioxide, and phosphorus reacts with oxygen, it produces phosphoric acid. These are the reactions when non-metals react with concentrate HNO3. Now, next, what is brown ring compound? Brown ring compound, it is the also identification of nitrate. Identification of nitrate, and here we should use ferrous sulfate, a nitrate salt, and solution of concentrate sulfuric acid. Here is the formation of a compound, that is FeH2O5NO. FeH2O5NO. It is the brown ring compound. So brown ring test is the test for nitrate. The reactions is NO3 minus plus Fe2 plus SO4 2 minus or 4H plus, that is from H2SO4, forming NO plus Fe3 plus plus 2H2O. In the second step, this NO used to make the FeH2O5 2 plus NO, forming FeH2O5 NO 2 plus. And when, as the medium is contains with sulfate ion, it in presence of SO4 2 minus, the charge is balanced, the FeH2O5 NO SO4. It is the brown ring compound. The name of this compound is hexaaqua nitrosoferrous sulfate. It is the complex nomenclature. So this is about nitrogen. Now the next, that is phosphorus. Now phosphorus we have already discussed. It is a non-metal, come in the waxy solid form, and the white phosphorus and red phosphorus are the two classification of phosphorus, and white phosphorus is very reactive, and red phosphorus is produced from white phosphorus but heating a temperature, and phosphorus comes with a tetrahedral structure, that is 4 phosphorus atom are joined tetrahedrally to form the molecules P4 molecule. So this is about phosphorus. Now how phosphine is an important gas, how phosphine is prepared. So laboratory preparation of phosphine is the concentrated aqueous solution of sodium hydroxide plus white phosphorus produces phosphine. So the reactions is phosphine, phosphorus plus NaOH plus H2O forming PH3 plus Na2HPO4. NaH2PO4. NaH2PO4. This is the preparation of phosphine. Next compound, that is phosphorus trichloride. So phosphorus trichloride, that is PCl3, PF3, PBr3, etc. Now PCl3. So we have already discussed these are of type ammonia, that is tetrahedral structure. Now how phosphorus chloride reacts with water. Here all the halides reacts with water to produce some acid. Here PCl3 plus H2O producing phosphorus acid, that is H3PO4 plus HCl. H3PO4 plus HCl. It is the product. PCl3 plus H2O, H3PO4 plus HCl. This is the hydrolysis. We have already discussed under the portion, that is PCl3 or NCl3 in this chapter. Now second point, that is the uses of PCl3 or uses of such kind of compound. It is used for halogenation of some organic compound, that is some alcohol and some acid, that is formation of acetyl chloride or formation of ethyl chloride from ethanol or acetic acid, that is CH3COOH plus PCl5 forming CH3COCl. This is acetyl chloride. It is a very important organic reaction. In the next class, we will discuss on the oxyacids of phosphorus and some questions. So carefully read the NCERT textbook equation and write it down for yourself. Thank you.